Welcome to ITEC 136, Principles of Programming. In this session, we're going to be talking about switch statements. At the end of this session, you should be able to identify where switch statements are preferable to if-else statements and vice versa. And you should be able to write correct program code that employs a switch to solve a given problem. Switch statements. What is a switch statement? A switch statement is really a shortcut to compare many values and conditionally execute code based strictly on equality. And that's the important part to remember. Things have to be an exact match. So this is good for a limited number of enumerable options. So if we can write down all the possible values reasonably well, and we can compare them based on equality, then that's suitable for a switch statement. But it's really bad for testing ranges of values or for deciding between two mutually exclusive options. Testing for ranges of values or deciding between mutually exclusive options is much better for if-else statements. So let's take a look at some examples. Let's say that we wanted to determine the point values of letter grades. So we're going to input a letter grade such as A, B, C, D, and we're going to output 4 for an A, 3 for a B, 2 for a C, and so on. Would that be more suitable for an if-else or for a switch? Really, this is best suitable for a switch. Why? Because it's a very small set of input values, and we can compare exactly based on equality of those strings. How about determining letter grades from a percentage? So we input a percentage, such as 85, and we output a letter grade B. That's much more suitable for an if-else than a switch. Why? Because we have ranges of numbers. So for example, 80 to 89 is a B. So we want to test that using a range. If we used a switch, we'd have to list all of them. 89, 88, 87, 86, 85, and so on, all the way down to 80. And that's a lot to do. It's much easier to test a range using some relational operators and Boolean logic. How about determining insurance rates based on age? So we input an age and we output an insurance rate. Again, that's testing ranges of numbers. The ages are ranges, right? So someone from 16 to 25 might get one sort of insurance rate for a car, but somebody from 26 to 30 might get a different range. How about determining the name of a month based on the number of a month? So I input 1 and I get out January. That's suitable for a switch. Why? Again, because it's a small set, 1 through 12, and we can compare these numbers based on equality, 1, 2, 3, and so on. How about determining a form letter salutation based on gender? So if their gender is male, we output Mr., and if it's female, we output Ms. That's suitable for an if-else. Why? Because it's only one of two options that are available. We're not selecting from among 6 or 7 different options, but there's only 2. So that's for an if-else. Here's the structure of a switch statement in code on the left and as a flowchart on the right. So we have a switch, the word switch, followed by some expression. And this expression usually evaluates to either be a number that's going to be compared on equality or a string that's compared based on equality. And then we have cases that match certain values. And so if it's value 1, if the expression is equal to value 1, then we'll do statements 1. If the expression is equal to value 2, then we'll do statements 2, and so on. Let's take a look in depth. We start by evaluating the expression. So we come in from the top and we evaluate the expression. Then we compare against value 1. When we reach value 1, if value 1 is equal to the expression, then we will execute the statements. The break statement means that then we're going to jump all the way out to the bottom of the switch. And so we follow the path on the right all the way down to the bottom. If it's equal to value 2, then we will skip over value 1 statements and execute the statements that are associated with value 2. If none of the values match, then we will execute the default. Now, you don't have to have a default, but if you do have a default, if none of the others match, then that's what we'll execute. Now, what happens, though, if one of these breaks is missing? If the break is missing, then we're going to do what's called fall-through execution. So let's say that value 1 matched, and we're missing the break after the case for value 1. So it will execute statements 1, and then it will fall through and it will execute statements 2. In other words, execution falls through doing all those statements until a break is encountered. So missing break statements can be the source of some bugs in your switches. So here's an example. Let's say that I had some prerequisites for courses. So I list some courses on the left and I list their prerequisites on the right. What I want to do is I want to input a course and I want to output what the prerequisites are for that course. Should we use a switch or should we use an if-else? Well, since this is a small set of enumerable options, this is easily implemented using a switch. So how would it work? Well, first, notice that some of these are in common. So for example, MIS 310 and MIS 320 both have the same prerequisite of writing 320. Likewise, ITEC 400 and ITEC 350 both have the same prerequisites. So this sets us up where we can take advantage of fall-through execution if we want to. Here's the code. We start by setting a result to some empty string, and then we switch based on the course. If the course is equal to ITEC 350 or the course is equal to ITEC 400, again, there's no intervening break, we'll fall through and we will set the result to be adding on ITEC 136 and Comp 204. And then we break and we'll exit out of the switch. The same thing happens for MIS 310 and MIS 320. They both have a prerequisite of writing 320, and so on. If none of the cases match, then we will execute the default, which alerts the user that this was an unknown course. These are the deliberate fall-through cases, and you can take advantage of these. These are the same things in if statements as ors, if the course is equal to this or that. And any switch can be rewritten as a series of if-else statements, but it's not easy to rewrite every if-else as a switch because if-elses are also suitable for testing ranges, which switches are not suitable for. So here is that same code rewritten as a series of if-else statements. So now you should be able to answer the following questions. What kinds of statements, what kinds of expressions are evaluated in a switch statement? So when we have that expression up at the top that says switch and then in parentheses an expression, what are the data types that can come in parentheses there? What kind of comparison do we perform against the multiple values in a switch? Give an example of a problem where a switch is a better control structure than an if-else, and vice versa, where an if-else is better than a switch. What happens when a break statement is missing from within a switch option? Water exists as 3 states, solid, liquid, and gas, at 1 atmosphere of pressure based on the current temperature. Given a temperature as input, you are to alert the user about the state of water at that temperature. So you're inputting a temperature and you're going to output a state of water. So there's only 3 states as output. Should you use an if-else or a switch, and why? Write a function that inputs a month as a number, that is 1 through 12, and returns the name of the month as a string using a switch statement in your solution. Write thorough test cases for the month function above. If you have any questions, please email your professor or ask on the course discussion board. Thanks.